In this session, I'll be discussing about the structural aspects of carbonyl compounds. When I say carbonyl compounds, aldehydes, ketones, carboxylic acids will be discussed. Then we will discuss about the preparation followed by the properties of carbonyl compounds. Let us consider the carbonyl compounds and its structure. So I think I already explained about this. When we say carbonyl compound means that is it has C double bond O and single bond. So this is sp2 hybridized, this is also sp2 hybridized. So we have three sp2 hybridized sigma bonds and one pi bond. You know very well about sigma bond. Sigma bond arises due to linear overlapping or axial overlapping. When you have two p orbitals, it can overlap like this. So axial overlapping, that leads to a sigma bond like this. Okay, so there will be a overlap. So this is sigma bond. And this can happen along with p and s orbital also. So in that case, it can form an orbital like this. Okay. So that leads to sigma bond once again. So it is axial overlapping. So sigma bond is due to axial overlapping. And it's very strong also. So you have sigma, sigma, sigma. And here you have pi. So the pi orbital is due to sidewise overlapping or lateral overlapping. So that leads to pi bond. So it can form a bond like this. So this is, it looks like dog's bone, so pi bone. This is due to sidewise overlapping. This sidewise overlapping leads to pi bond. Of course, sigma bond is stronger than pi bond. In fact, pi bond is weaker. When it is rotated, it has the tendency to break. And that is why it's very sensitive and it can form easily products. That is, it can easily react. And particularly when it is bound with the two differently electronegative atom. Like in the case of carbon, this is less electronegative and oxygen is more electronegative. So because of the difference in electronegativity, there is a chance of transfer of pi electron. So this oxygen has already a pair of electron. Two pairs of electron. They are called non-bonding electron or lone pairs of electron. Now what happens? This pi electron can move over to oxygen. It can transfer to oxygen. Because of the difference in electronegativity. Oxygen is more electronegative. So it can attract the electron towards itself, and thereby it becomes delta minus, and this may become plus, and that is why you are able to get plus and minus here. So what are the key points about the structural aspects? Since it is sp2 hybridized, it has the triangular planar structure. So you can observe here a triangular planar structure. And that too, since these are all, that is after the pi electron transfer, it may attain the symmetric triangle like this with 120 degree angle. Okay, so what happens? All are in the same plane. Of course, this pi bond is perpendicular to the sigma plane, sigma bond plane, that is indicated in yellow line here, yellow highlight here, whereas this is perpendicular. So let me note down the key points here. The carbonyl carbon atom is sp2 hybridized. This is very important. Second point, forms a 3 sigma bond. So 3 sigma bond and the fourth valency electron. The fourth valency electron, that is due to pi electron. So it forms a pi bond. So 3 sigma bond and 1 pi bond with oxygen. Pi bond with oxygen. Then it may overlap with the p orbital of the oxygen. In addition to that, this oxygen has 2 non-bonding electrons, non-bonding electron pairs oxygen. And then the carbonyl carbon and 3 atoms attached to lie on the same plane. This is called coplanar. So lie in the same plane. Which are lie in the same plane? The carbon atom and the 3 atoms, the other 3 atoms. They lie, the carbon and other 3 atoms lie on the same plane. And the pi electron cloud is above the plane and below the plane. So this pi cloud will be formed above the plane. Above the plane means, that is, let me indicate with a blue cloud like this, and below the plane like this. And then that is the bond angles is 120 degree. So you have to mention about the bond angle also, 120 degree. And this is expected to be a trigonal coplanar structure. So what are the key points? So based on that, you should be able to arrive at the concept map here. So we talk about the structure. So the structure of carbonyl group. Carbonyl group is this one. So I am going to talk about this. What are the key points here? Point number 1, that is sp2 hybridized. And point number 2, that is 3 sigma bond and 1 pi bond. Then they are all coplanar, okay? And this is a carbon atom and other 3 atoms. So C and other 3 atoms, they form the coplanarity. And this coplanar, since it is sp2 hybridized and they have the bond angle, so we talk about the bond angle here, that is 120 degree, and this is trigonal coplanar. And we talk about the pi electron transfer also, so you can mention about that, pi electron transfer. And also, because of this pi electron, why this pi electron transfer? Because of difference in electronegativity. So this aspect will be discussed in the next point, where we talk about this C double bond here. C double bond O, and there will be a transfer of pi electron. And because of this, you are able to get minus and plus. So this difference in electronegativity, that is to be noted. And due to higher electronegative oxygen compared to the carbon, there is a transfer of pi electron. Therefore, the carbon is electrophilic. The carbon is electrophilic. It means Lewis acid. Carbon is electrophilic means that is they are attracted by the electrons. That is Lewis acid. We know Lewis acid. What is Lewis acid? That is capable of accepting the electron. And the other one is nucleophilic. That is the oxygen is nucleophilic. Now, the polarity difference is explained based on this pi electron transfer only. And this involves a resonance that involves a neutral A and B structure. So that is shown here. What's your doubt? Any doubt?
Sir, previous slide as the words not very well.
Okay.
Yes, sir.
Is it okay now?
Yes, sir.